Hey, Algebra, here we are, second to the last chapter, doing the extra credit, and super excited here because because you've caught up with my other algebra at the other school, so now I have had to make 3 tests and 2 extra credits, and I've done this a lot, and I'm like, it really is fun. If you do it for a while, it is fun. So I'm not sure if you agree with me at this point, but cool stuff. Anyway, I had started to do this before and then got a parent trying to contact me from the other school, so I wanted to take that. So I'm just going to restart over here, and stay tuned because at the end I'm going to show you the note sheet that's going to come with the test, so you will know which formulas are on there and what things you may need to memorize and what you do not. All right, so we talked about looking for our pattern here, and although the ratio is this over this, which is a fourth, it's also, you're also looking for that pattern. And for some of you, it might be easier just to realize you're dividing by 4, dividing by 4, dividing by 4, which is the same as multiplying by 1/4. But then you have to continue it on. So 80 divided by 4 is 20. Divided by 4 is 5. And divided by 4 is 1.25. You could have written there 1 1/4, or you could have written 5/4. Either would have been correct. Or any of those 3 would have been correct for that last one. All right, so the geometric sequence, and I notice I have that on the note sheet, which I'll show you more detailed later, but I do have that formula on there. Now you could challenge yourself and see if you could memorize this, or if you already know it by heart and then only use the note sheet if you need it. And if you don't end up needing it, let me know. I'd love to hear that kind of stuff. So let's take a look. The first term of the geometric sequence is -2. So remember, when you see first term, that is a sub 1. Because that little 1 means first term. First term. That whole thing means first term. So I know the first term here is -2. So I'm going to put the -2 in place of that. And the common ratio is 3. Okay, well, that's my R. So I'm now going to put a 3 in, and I am going to put it in parentheses to separate that a little bit. And it wants to know what is the 12th term. Okay, so the way we would write the first term was with the 1 here. If we want the 12th term, we would put a 12 there, and that is your n. So then the power becomes 12 minus 1, because that's what your n is, n minus 1. So that becomes a -2 times 3 to the 11th. Now I brought 2 calculators today, just in case you guys had this one. Not sure which ones you guys have, but I've always shown you on this one. So I would have done, let me just show you with this calculator, 3 raised to the 11th equals times 2 negative equals -354,294. Okay, so now let's look at with this calculator. If you take the pink one, some of you might have this key right here. That's the little caret key, and you can use that when you're doing a power. So what I would do is something like this where let's make sure it's on. Hope you can't see the whole thing. Okay, so 3 raised to the, so I push that caret button, 11. It looks like that, equals, I don't know why those negatives are showing up. Let me clear this out. That shouldn't be in there. 3 raised to the 11th equals, and then I would go right away to times -2. See, on this one I put the negative first and then the 2, but on my other one I put the 2 and then the negative. So you got to kind of learn how your calculator works. But if you do it right, the answer is the same. So make sure you know how to use your calculator before you do the test. All right, now I know number 3 caused some disgruntlement with with some of you guys, so let's get that all cleared up. First of all, I put this chart here because I wanted you to have some practice with it, because you will be graphing one like this on the test. So I wanted you to be familiar with making yourself an XY chart. Typically what you're going to want to do with one of these exponential type forms is, pick your 0, and then we want to go 3 to the negative and 3 to the positive, and that will be just fine. And you may or may not be able to plot all these. That's okay. We can still fill them in. So let's look at how we do that. I'm going to start with the positives because they're a little easier, and hoping that and I'm actually going to do the work over here so you can see it. So if I put in 0 for my x, I get 3 times 1/4 raised to the 0 power. That's a 0, not a 6. Excuse me. So if you raise something to the 0 power, what do you get? 1. This whole thing right there is 1. Times 3 is 3. Okay, so that one coordinate, 0, 3, because this is multiple choice, already has us narrowed down to the top or the bottom graph. Those are the only ones that have a 0, 3. There it is, and there it is. But I will be honest with you, that's not going to be a multiple choice tomorrow on the test. So you do need to know how to do this. And let's do the 1 next. So I would have 3 times 1/4 raised to the first power. What's a fourth to the first power? A fourth. Times 3. And remember, you can put it over 1, so you'd have fractions. So 3 times 1 is 3, and 1 times 4 is 4. It's 3/4. 2. Okay? 3 times 1/4 raised to the second power. Okay, again, we can put this over 1. And now remember, when you square it, you square both of them. But see, 1 squared is always going to just give you 1. But the 4 squared will give you 16. And when you multiply across the top, you get 3 over 16. All right, and the bottom one, 3 times a fourth to the third. So again, I'm going to write 3 over 1. And then 1 to the third is 1. And 4 to the third is, anybody know? Now you can use your calculator. It is 64. So I have 3 times 1 is 3 over 64. Okay, now let's look at the negatives, because if you forgot about negative powers, this might have tripped you up a little bit. So we have 3 times 1/4, sorry, this should be a bigger 3, to the negative 1. Does anybody remember how you get that power to be positive? That's right, you take the reciprocal. Very good. So you have 3 over 1. I'm going to write it as a fraction. That didn't change. But to make this a positive 1, I flip this. Now it's a positive 1. And it's just the same because you're raising it to the first power. So 3 times 4 is 12 over 1, which is 12. You can stop one of these if you want and try it yourself. Oh, I keep writing that 3 so small in the front there. Now we're going to the negative 2. So again, I'm going to write the 3 as a fraction. To make that negative 2 a positive 2, I flip the fraction. The 2 stays, but it becomes positive. Now I get 3 over 1 times 16 over 1. 3 times 16 is 48. Very good. And over 1 times 1. Okay, we're getting pretty big numbers, but let's just finish it off for good measure. So we have 3 times 1/4 to the negative 3. Again, wrote that 3 small. I don't know what my problem is there. And I'm going to write it as a fraction now, times, to make that a positive 3, I flip this, what's inside, and now I have a positive 3. I still have to cube it though. So I have 3 over 1 times, what is 4 to the third? Just said that, it's 64. And 64 times 3 is 192. Okay, so that is how a little review on those fractions there. So we knew we were down to these two graphs, the top and the bottom. We got to look at some of the other points now. Let's see, negative 1, 12. Negative 1, okay, no, that's not that one. Let's look at the bottom one. Negative 1, 12. Ding! 1 3/4. 1 3/4. Yep. 2 and very small, and 3 and even smaller, and yep, that is exactly it. So the answer is D. So I hope that clears up any confusion you might have had. All right, number 4. It gives you the function about bacteria, and it wants to know how many bacteria will have grown after 5 days. Well, since it tells you right here that X is the number of days, that means we're trying to find F of 5 days. So I don't really do anything, that's just the notation. I'm going to do stuff with the right side. So I'm going to do 1.2, and it's raised to that X power 5. So again, you don't multiply those first. I'll use this one again just in case you need to see that. Clear. So I'm going to do the 1.2 raised to the 5 first equals. Now I multiply it by 50. Oh, whoops, it does say to round, doesn't it? Nearest whole number, so it's 0.4, so that means it's 124. All right. So far, you can kind of see what's going on, how much work I expect to be shown. So I like the formula, plug in the numbers, and then get me the answer. Plug in the numbers, show me the answer. Plug in the numbers. If you do use a calculator here, that is fine, but I would make sure you're using it properly so you're not making mistakes. To me, it's clear just to write it out. All right. Which set satisfies an exponential function? So remember, first of all, you check your x's. They should go increase by the same amount. So let's look. -8. Uh-oh. That's way more than 8. So it's not A. Okay. +1, +1, +1. Okay, it could be that one. Let's check this one out. 1, 1, 1. No, there's no increase. 1, 2, 3, 4. Okay, it could be that one. So I've checked the x's. Now, the y's have to be a growth. They have to be multiplied by the same thing. So you need to look now at the y's and see, is there a common thing they're all multiplied by? The answer is yes. 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. Well, because it's a test, I want to make sure I didn't make a mistake. So I'm just going to double check the other one. 2 times 2 is 4. If I multiply that by 2, I get 8. No. I have verified. Number 6. The number of members in a labor union is 240, and it increases. So this is what, guys? This is called an exponential growth formula. That is also on there. It grows. So that is the formula you'll want to use. So you should write your formula down. And now you need to know where everything goes. Well, A is what you start with. So that's my 240. Start with 240 people. 1 plus R is your rate as a decimal. So you move it 2 spots. It's 0.05. Make sure you move it 2 and not 1. It's not 0.5. 0.5 would be 50%. Okay. Let's see, where am I? T. That's the number of years, and that's pretty straightforward in this. It just gets a little tricky if you do half-life, but it's 4. Or if you do the compound interest as well. That gets a little tricky, actually. All right, so 240, I can add those. That's 1.05 to the 4th. And now again, you do the power first, then you multiply. I'm going to use my other calculator in case somebody has that one. 1.05 raised to the 4th equals times 240 is 291.72. Find the number of members. Okay, well, members are whole numbers, right? We can't have part of a person. I would venture to say 291 because we don't have 292 yet, but a lot of times they'll say round to the nearest whole number. So I actually, in this case, would accept either because they're not really very clear. At least I didn't think so. the official right answer according to the answer key is 292. But I fight with that thought because as we're talking about people and we don't actually have that many people. We have this many and part of a person. So, all right, let's go to the half-life. Again, half-life is on there. Oopsie, right there. So we will write the formula. And let's take a look. This one is a hinge trickier for the T, but the P is, again, what you start with, and it was 100 grams. The difficulty, because it says, now this, you guys, is the name of something. We don't use that number in anything. Oops. Hello, how about I get on the camera, guys? That would probably be helpful. All right, is that better? This is the name of an element. Okay, so that 212 is nothing you're using in this formula. Okay, it's part of the whole chemistry thing. What you're using is the amount that they started with. So they have 100 grams left after this many minutes. So the T is the number of half-lives that occurred. Well, every 60.5, that's one half-life. So you have to take your minutes and divide by how much one half-life is. And what you're going to find out is that is 4 half-lives. We have 4 sets of these. And that is the T. Okay, so that is a hinge trickier when you do half-lives. Okay, unlike up here where the T was just your straight number of years. Again, grab the calculator. See, 0.5 raised to the 4th equals times 100, and we get 6.25 grams. All right, let's move on. The extra credit video gets long. If you need to, go ahead and take a break. Come back to it. But it's so important. So important. All right. Which describes the data? Okay, well, first you got to plot it. So make sure you're plotting correctly. -2, 1. Because if you go -2, 1 and throw it up here, you didn't look at your graph carefully enough. It's 4. Okay, so 1 is only about 1/4 of the way up that line. -1, 2, that's halfway up the line. 0, 4 is right there. 1, 8 is there. 2, 16 is there. All of a sudden we're taking a curve, aren't we? Exponential. If it was quadratic, you would have had a U. If it was square root, you would have had a curve like that. And if it was linear, you would have had a straight line. All right, find the domain of that. Again, the domain is what values can x be? And the answer is x can't be anything that's going to make this negative. So that's why we take whatever's under the square root and set it equal to 0 and solve to get our boundary line, the crossover line from where it goes from to negative numbers. We need that crossover line. So we solve. Okay, that's just normal solving work. But that's not my answer, kids. Because guess what? I could put in 3. What's 2 times 3 is 6 plus 7 is 13. That's a positive number. There's a lot of positive numbers, not just one. Okay, but this, when I put in -7 halves here, I'm going to get 0. So if I go below this number, it's going to go negative, and I can't have a negative square root. Okay, so it has to be this or bigger, all those numbers. So you have to write your answer like this. Greater than or equal to -7 halves. All right, now the translations and the piece with that. Golly, I don't have my test or my book right here. I thought it was $7.99. Boy, if that's the right page, I'll be surprised. But there is a page that shows all these translations, and if you want it and you can't find it, email me. But it shows that when you add things outside of the square root, like this is not inside the square root, it's a vertical shift of that amount. So +4, okay, go up 4, boom. That's your answer. Okay, you don't have to do anything more with this. I want you to just understand the shifts. Now, if it's underneath the square root, then it is a horizontal shift, and it's the opposite. So if it was the square root of, let's say, x minus 2, then this would have been not negative 2, you would have gone positive 2, and it would have looked like this. Okay, because that would be a horizontal shift. So there's a difference, but if it's on the outside or the inside, again, I'm guessing. My memory at 10:30 at night probably isn't very good, though, so let's just face facts. It's probably wrong. So email me if you'd like that page. All right. Now, simplify. All right. So this is where the part of the test, let me look here, and on. The calculator does not really help you very much because anybody can punch in square root of 800 and get a number. You're simplifying this in simple radical form. So you need to break this down and you need to think of numbers that are perfect squares. And the answers to those are 4, what else? That's 2 squared, 3 squared is 9, 4 squared 16, 5 squared is 25, 36, 49, 64, 81, 100. Okay, we're looking for factors that are those. So can you see one that's a factor of 800? Because I do. 100. Okay, so we can split this up into square root of 100 times the square root of 8, can't we? We probably could have even done bigger. Actually, I know we could have done bigger. But we're going to start there. So you get that, and you say, okay, am I done? No, we're not done, because that can be broken up into 4. And whenever we can find one of those perfect squares, we're not done yet. So square root of 4 is 2. And now I multiply them. 10 times 2 is 20, root 2. All right, so number 12, a 30-foot pole is stabilized by a wire. Okay, so we're going to use, what's it called? We're going to be using Pythagorean theorem. Hopefully that is one thing you will have to remember. A squared plus b squared equals c squared. And the a and the b are the legs. So we'll put in 30 squared plus 10 squared equals c squared. And we need to break it down to simple radical form. So when you square it, you get 900 plus 100. So you get 1,000 equals c squared. Okay, so we are talking about finding out the length of this. So we don't want c squared, class. We want c. Okay, we had c squared because it was part of the formula, but our answer here is c. This is a, this is b, and this is c. So in order to do that, we need to undo that square root, and I get this. But that is not radical expression in simplest form. So we need to break that down. Square root of 100 times square root of 10. And what is that? 10 root 10. And there is a unit, so I'm going to put feet. I'm going to box it, and I have all my work nicely shown so I can see exactly what's going on. So make sure you guys do the same. All right, simplify this. I recommend you take these, break it down, and put the number in one, and put the variable in the other, so you can look at them separately. Because they're multiplied, you can do that. Now again, when I'm looking at the number, I'm trying to look up here. Does anything in here, can you divide 50 by anything in here? Yeah, how about the 25, right? So we break that down. Square root of 25, square root of 2. These have to multiply to give you 50. It does not help me to say 5 and 10. Okay, because 5 and 10 aren't perfect squares, and you get nowhere. The only reason I pick these is because this is a perfect square. And I can get 5 root 2. And now let's go over here, though, because I still have this to work with. Okay, this can be broken down because every time I have an x squared, we know these cancel out, and I'll get an x. So I have 1x squared. I have 3 of them. So I have 2 and 3. So I can break it down and look at it that way as well. So I've got an x there, and then I have a square root of x. That doesn't break down anymore. So now let's look. This is all multiplied together. So we can put the 5 and the x together, 5x, and we can put everything under the square root together too, because there's no adding and subtracting in here. Okay, when it's adding and subtracting, the rules are a little more stringent, as you know. All right, well, let's look at adding and subtracting. You can add and subtract when what's under the radical is exactly the same, and it is. It's 2n. So we got 10 of those here, 5 of those here. So I add those two numbers and get 15, and what's underneath it stays exactly the same, 2n. Done. It's one of the few ones there won't be work for. How about this one? Is what's under here the same? Nope. So I can't just go ahead and subtract, that's for sure. But the question is, can any of it be reduced? Well, if you look at the 3b, the answer is no. No. 3 can't be reduced and neither can b. That's just the way it has to be. But when I see that 12, I know that one of those numbers, 4, 9, 16, 25, 49, 64, 81, and 100, one of those numbers can factor out of that. So what we're going to do is I'm going to leave the 5 out front, and I'm breaking down the square root of 12b into two things, square root of 12 and square root of b. Why? Because square root of 12 breaks down into 4 and 3. I'm going to carry down these other two. I don't want to forget them, so I'm just bringing them down for the ride. That is 2. So I've now got 5 times 2, square root of 3, square root of b. Okay, we can put these together because they're multiplied. So 5 times 2 is 10. 3 times b is 3b. Minus 3 root 3b. Now are they the same? Absolutely. Isn't that cool? So these are the same, and now I can subtract 10 minus 3. And we're done. The next one says multiply and then write the product in simplest form. It's because there's nothing to simplify the way it is, but sometimes when you multiply them together, then you can break them down and simplify them more, and that is the case here. So let's multiply 33 times 6, and that is 198. P times P is P squared. So, like I said in that other problem, split up the numbers so you can look at those separately and split up the variable. One of those is super easy. The square root of P squared. Remember, the square and the square cancel each other out. You're left with P. Done with that. This one's a little harder to see. You may need to go up here and try some of those to see which one it is. But guess what? When I take 198 and I divide by 49, guess what? Oh, no, it's not. I thought it was. 98 divided by 49. What? It is not. I'm wrong. So let's see what else is up here. It's got to be something. 198 divided by 16. Nope. 198 divided by 9. Ding! Comes out as a whole number. 9 times 22. Let's make sure we didn't make a mistake. Yes. Square root of 9 is square root of 22. Square root of 9 is 3. Square root of 22, P. So how can we simplify that? We can put the P out front with the 3. 3P square root of 22. All right, 17. Now, because we have adding and subtracting in both, it's like a FOIL. It's where you have to take both of these terms. We have 2 terms here and 2 terms here, and we have to multiply them all. So you're going to get 4 terms. So let's do that. 4 times 3 is 12. 4 times a negative square root of 2 is minus 4 root 2. Now we go to the next one. Square root of 2 times 3, always put the whole number first, plus 3 square root of 2. This is difficult. Rewatch it over. And lastly, square root of 2 times square root of 2. And it's a negative because we have a positive times a negative. So get rid of that. It's a minus square root of what? 4. You multiply what's under the square roots when you're multiplying. So that's nice. That comes out to 2. So I've got 12 here. What happens with that? There's two things being added, and they both have the same radical here. So we have a negative 4 and a positive 3. So that is a negative 1, or just a negative root 2. And that was a minus. So I'm pulling everything down. 12 minus 2, I can put the whole numbers together, is 10. Right there. All right, now this quotient, the problem, well, there's a couple problems. Problem is this is not simplified, but in addition, you can't have a square root in the bottom. So first, let's simplify it, because that's going to be the shortest way for you to go. Square root of 27 can be broken down into square root of 9 and square root of 3. Again, you're picking two numbers where one of them is a perfect square. That is 3. So basically, this is equal to, oops, square root of 7. Okay, so that's where our first step. So we simplify the square root of 27 to this. But now we still have this square root in the bottom. This is fine. The 3 can be fine. I can't have the square root of 3 there. So you're going to multiply the top and bottom by the square root of whatever number is inside of there. So I see a 3, so it's a 3. If it was a 10, it'd be a 10 and a 10. And the reason is, well, first of all, we multiply these two. 7 times 3 is 21, and that can't be reduced. I got the 3 on the outside, so I'm going to put that there. But square root of 3 times square root of 3 is square root of 9, which is 3. That's why you do that, because you get 3 back. Now I have square root of 21 over 9. We are all done. All right, 2 more to go. Hang in there. All right, when we're solving, see, notice up to this point there hasn't been any solving. Now we have equal signs. Once you have equal signs, you're breaking it down like you used to. You want the x alone on one side. Okay, and if there's a square root involved, you want to get the square root alone. So this 5 on the outside, we want to get rid of. So I'm going to divide both sides by 5, and we end up with that. So we have to get rid of the square root, and the way we do is by doing the opposite of square rooting, which is squaring. Because remember, the square root and the square cancel out, and you're left with x, and 9 squared is 81. Common mistake, people forget to square this. You got to do it to both sides. Next one. Okay, so I've got the square root alone. This gets a little more complicated. Kudos to anybody who got this right. I am very curious, because this was definitely the most difficult problem. And you can let me know if you did get it right, because I would love to know, and I don't always have time to look at all the details. So please feel free to shoot me an email and say, I got 20 right, and I'll be like, yes. All right, so the square root's alone, so we got to get rid of that first. So we are squaring the whole thing on both sides. So it's fine and dandy here. I just get a 4x. But do you see what happens here? X minus 3 squared, remember, is this. X minus 3 times x minus 3. So we got to FOIL this out. Get an x squared minus 3x minus 3x plus 9 equals 4x. Combine like terms on this side of the equal sign. Good review here. Get the 4x on the other side so that those are together. As you can see, I have a quadratic here at this point. And we need to see if we can factor two numbers that add to give you a negative 10 or multiply to give you 9. How about negative 1 and negative 9? Does it work for both? It does. So that factors into x minus 1, x minus 9 equals 0. And do you remember how we tell the solutions? We're looking for the 0 property tells us one of these two have to be 0. So what would make this 0 if that was a 1? So x could be 1, or what would make that 0 if x was 9? But not so fast. You have to be super careful, because guess what? Because you have a square root in here, remember square roots can never equal a negative number, at least in the real number world. So we have to check to see if either of these is going to yield a number that is negative. So let's just take a look. I rewrote it right here. If I put a 1 in for x, what happens? Yeah, I mean, the right side looks great, right? Square root of 4, 2. Oh, it's all working out fine. Negative 2 equals 2. Nope, it's not. Because a square root can never equal a negative number. So 1 is not an option. Does 9 work? When I put 9 in here, do I get positive? Sure, 9 minus 3 is 6. So that's a positive number, and that would be just fine. So this is my one and only answer. So don't get fooled by that, guys. All right, so super excellent. I hope this review was very helpful. I'm actually going to set up a Teams meeting tomorrow, too, for anybody who still has any questions on this. So look for that in your email. Here are the notes. So this is exactly, let me put this up here. This is exactly what you'll be given with your test. Okay, and then that's it. So you'll get the sequence, exponential growth, exponential decay, compound interest, and half-life. Okay. Haven't really had any compound interest problems. I wouldn't panic about that. I'd be more concerned with the 3 right here and the half-life. Hint, hint. All right, guys, and ladies and gentlemen, I hope you have a wonderful night. I hope you are super ready, and please knock this test out of the park. Okay, take care. Bye-bye. God bless.